13 in our evolution unit. So our evolution unit, if you look at it in the big picture standing back, it's 17 activities. You'll see I've color coded it by the type of activity. The absolute beautiful piece of this curriculum is that you start out doing before you get to the like sit down, let's read this content and get super, not I want to say super serious, but that idea that we get to build these shared experiences. So the program was designed so that we level that playing field, that students get to build experiences common together, because you know you have some kids that go to the museum every weekend and some kids who have never gone to a museum. So how do we make sure that it's an equitable situation? They're going to work on this together. So by the time they've gotten to embryology activity 13, you can see that they've worked through several pieces of evidence of evolution. The full course, activity 1, is about bacterial resistance, and so that evolution of bacteria. And then hiding in the background, we talk about natural selection. Meaty of Minds is Darwin. Battling Beaks is Beaks. And you can see we go all the way, all the way, all the way. Activity 9, we start looking at fossil evidence. So what evidence do we find in the fossil record that supports this idea of evolution? Activity 12, I will catch you up on because it leads right into embryology. For this activity, we align all of our curriculum with our next generation science standards. Our disciplinary core idea here is evidence of common ancestry. For science and engineering practices, how do we analyze and interpret data? It's my favorite one. And then of course, cross-cutting concepts of patterns and structure and function. This activity introduces the word embryo. And of course, patterns is an introduced word that the students already have. Yesterday, so in class, activity 12, we would say, oh, remember when we looked at the evolutionary relationships of whales? So we looked at whale evolution, and we saw that over time in the geologic record, we have found these patterns of how whales evolved. And we looked at whole skeletons to do that. So we had these little cards and kids got to sort them into groups, and we got to talk about what happened, what were the patterns, and what is the structure and function that led whales to be what whales are today. And lo and behold, we discover that whales came from a land ancestor. And that is going to bring us into today's activity, which is another way to examine evolution is by looking at embryologic development. So embryos. And then reminding kids may have never, an embryo is the developing animal from fertilization through birth or hatching. So we're going to look at embryos today, guys, and we're going to be able to see what patterns. We're going to analyze these patterns. So I'll give you a few seconds to go ahead and read the introduction. So your student book, this is in your student book, but go ahead and I'll just be quiet so that you can read that. Our goal today, so our guiding question, each activity after the introduction has a guiding question to support students in what am I supposed to make sense of today? How can embryos provide evidence about evolutionary relationships? Great. The first activity, which were procedure part A, we're not going to do. I'll show you, but we'll skip over this so we can get to part B. Part A, students would get a piece of paper, or if you're remote, you would screenshot that from the digital version and put it on Jamboard or whiteboard or another interactive program that you're using. Could be a Google Doc or Google Slide, however you're sharing materials. And students are supposed to look at these structures, these four limbs of these different vertebrates and decide what's similar. Do they notice any patterns? And so of course we start with the human and we talk about, we've got the upper arm and the forearm and the wrist and the fingers. So those are kind of easy to start with and find. And you'll have kids color code those different features. So upper arm, lower arm, wrist, fingers is okay for vocabulary. If you want to get humerus, radius, ulna, great as well. So you can kind of scale that and differentiate that for your group of kids. And you decide, okay, the upper arm is going to be whatever color, orange. Now I want you to find those similar structures on the other vertebrates and let me know what you think. And it's all, you know, good and well until we get to the wrist, and then it becomes, wait, miss, this doesn't make any sense. I can't find this. And that's exactly what we're looking for in our students, to say, wait, this is kind of hard. Well, how do I figure this out? How are you going to use evidence to make a claim here? So you let kids try and they talk together, they're in their partners, they're in their groups, and then you show them the correlation and they get to, you know, like, what? The horse, the whale, what's happening? Oh my gosh, I had no idea those were the fingers or wrists or whatever. And then you ask them, do these patterns mean anything? Have that discussion. Then we move on to part B. Part B is a simulation. So Mari's going to put that simulation in our chat. And I want you to click on that simulation. And when you do, you'll have an opportunity to take these cards and drag and drop them into the correct spot, or at least the spot you think is correct. When you do that and you're feel like you're confident, you can go ahead and share your screenshot to our whiteboard. So I've got a link. Mari will post that on the chat as well, so that our common whiteboard, we can kind of see what you guys are coming up with. So I'm going to call a quick on your mark, get set, go. Get to the simulation, mess around, screenshot, go. So you're just dragging and dropping.
Donna said the program will not load for her and said it works in Firefox.
Okay, great. I'm in Google Chrome, so I'm not sure if there is an issue with maybe Microsoft or whatever, but yeah, try to see if you can problem solve that. And then let me know about the whiteboard. I'm experimenting with the whiteboard. I usually use Jamboard. So see if you can access that link if you open the whiteboard and just drop in your screenshot.
It looks like we're getting a couple screenshots in the chat. Is the whiteboard link not working for you guys, maybe? I'm getting a lot of head shaking now. The whiteboard cannot be found. So all of the screenshots are being dropped in the chat.
Okay, great. Let me see. The other thing I can do is post a Jamboard really quick. And then we can kind of problem solve that way too. Recent jams, so that we can all see it together. Let me see if this works. as you are finishing up, someone unmute and let us know, what do you think your kids are going to say? What do you notice about this?
Maybe looks like my hand.
Oh, great. Yeah. So this kind of looks like my hand. How hard was it to figure out the hind limb of?
Yeah, what's a moose hind limb?
Oh, does it say moose?
No, it says mouse.
Mouse. Yeah, the mouse.
That's not, that's me.
I was like, oh no, does it say moose? Let's see. Let's see if this Jamboard works. I'm going to put this Jamboard link. I just posted that link. Click on that and see if you can go to this document here and then see if I can copy and paste some things. Ooh, I see a couple people joined. Great.
It works.
Great. And so now if you can can you paste your screenshot here? Let's see if that works. Because it looks like I'm trying to open. Oh, there we go. Look at that. So we can move around. You can have kids share. You can have groups work together. Google Meets. How can groups? Thank you for dragging that around. For Jamboard, you know, at the side, there's these little sticky notes. And so we can give you feedback on your Jamboard, and we can look and say, huh, this is cool, and compare people's work. I wonder, so I see the early stage is definitely different for both of these students. I wonder why that is. Late stage looks pretty similar, doesn't it? So yeah, you guys both have the same late stage. I wonder why that is. And so we're looking for these patterns and asking kids, you know, what does this mean? What are we noticing? What do you think? When you feel ready that you would like to move on, let me show you the answers here. So here is the correct order of the limbs classified for the bat and the mouse, depending on if I'm thinking hind limb or forelimb. So yeah, that late stage seemed to be the easiest for people. The middle stage for the bat, the forelimb, okay, but the hind limb of the mouse and the bat, and like, oh my gosh, like how do I know that between that and like, what does this mean? Like, what does that mean for evolution and evidence? So now what I want you to do is go to, at the bottom, it'll say, go to the whole skeleton. And so ignore this share to your whiteboard since that's not working, and go ahead and mess around with the whole skeleton part of the simulation. It's just the next click, and they're gonna make you pull down the early stage before you get the middle stage cards. So go ahead and do that. And when you feel comfortable, I will scroll over on page 2 of the jam. So if you go to page 2, we can now post our whole skeleton screenshots. So I'll give you a few minutes to work on that. Mari, we could do breakout rooms if people would feel comfortable doing that.
Yeah, sounds good to me.
So you could put 3 people in a room maybe?
I will get that set up right now.
Great. So we'll put 3 people in a room and you guys can have discussion and be a smaller group and maybe talk about what your kids might think and how you could use this to support evolution.
Laura is asking if it is the exact same simulation as before.
It is the whole skeleton part. So when you go to the bottom, on the bottom of the screen where it says, let's see here. Can you see the bottom here? Go to next whole embryo card. So that's how you'll move on to the next part of the sim, and then it'll be this. Then you click off, and then you can drag these guys down.
All right, the breakout rooms are now open. Would you like me to bring them back? Okay, you're muted, by the way. There we go. I closed the rooms, so they should be on their way back.
No, it took forever to get to the rooms.
I know, it like showed up on here and like it showed certain people like in a room alone, so I like moved everyone around and then like it literally would glitch and not like put them in a room, but it wouldn't let me move them. I was like, no.
Well, and it was like, yeah, because I got moved and I was like, why is this taking so long? But whatever, it worked. And I heard a couple of good pieces of conversation. So,
Okay.
Let's see, do people have anything on the Jamboard? It doesn't really matter here. All right, as we all come back together, looks like we're still waiting for some more people. Francis, did you notice anything that you wanted to share or?
It took us a second to figure out like how to get the next row.
That you have to do all of the early
Yeah.
before you can get to the next row. Exactly. Yeah. In real life, in person, we have cards. And so on those cards, you actually, as the teacher, would hand out that early stage first and let kids sort through that before you hand it out middle stage and then late stage. So the simulation was trying to model how it would work in person. Yeah. Laura or Jennifer, anything you guys noticed that you wanted to share?
I just feel like the middle stage, like that threw me initially. So I feel like my students would have a difficult time doing that and it would cause a lot more collaboration on their part. So I did enjoy that aspect.
Yeah. And thinking about like, why is it so hard? What does that tell us about evolution? Right? Like that's what I love about this activity is, yeah, it's hard because at the early stage, a lot of embryos look the same. And then thinking about like what embryo was super easy to figure out.
Salmon.
Exactly. And then thinking about why that is. Why would it be easier to figure out the salmon than the other groups? So let's go back to our slide here. I went ahead and screenshotted the correct answer. In your teacher edition packet, you would get the correct answer. You guys can still see this, right?
We cannot see your screen currently.
Okay. It's probably because I'm not sharing. Thank you. So that idea that in person, you're walking around and you are looking at what students are doing and you're going from table to table and you're thinking, oh, this is cool. Tell me more. What do you notice? For virtual, what we found out is Google Meets has breakout rooms that actually work pretty well because you can monitor them all at once. Instead of like Zoom, you kind of have to enter and join and leave and join. And today we even saw that Zoom can be kind of glitchy with breakout rooms. It took a long time for me to join a room. But with Google Meets, when you put kids in a room, you're really looking for that discussion. That's the piece that you want out of this. What do you notice? So as we look at the final answers, the snake is just awesome. Whoever thought to even notice what a snake embryo looks like? Most humans, kid, adult, get the early stage of the human wrong, which I think is fun, like the bat, like what is this facey thing looking? And then the chicken, right? And again, that chicken, wow, that's pretty darn cool. So we're using pictures of embryos to look for patterns to support evidence of evolution. Those cross-cutting concepts with next generation science standards is really what you're focusing on. So you're going to ask your kids, like, how does this cross-cutting concept relate to this activity? We do have analysis questions at the end of each activity. So in that 17 activity unit, this activity 13 would end with, was it easy or hard? I know I taught this with 8th graders, and my 8th graders hate being wrong. They hate not knowing the answer and it not being really obvious. So they got really frustrated. And I thought, this is a great opportunity to guess what? This is what science is like. Science can be frustrating. If we knew everything, then there would be nothing to discover. So what does this mean? For analysis question 2, the students are keeping either a digital notebook. I know that some schools even remotely are having kids keep a paper notebook that hopefully eventually they can bring back to school. And then they can screenshot that, they can hold it up to the camera, but that way of getting kids to describe what patterns they noticed and when did you see arms and when did you see legs? And I hear kids, well, like, this can't be a human, we don't have a tail. Oh, that's interesting. Let's think more about that. And of course, with structure and function. If we don't have a tail, why does our embryo have a tail? What does that have to do with evolution? Interesting. And then of course, what relationships across different species can you see that you can't see when they're the mature skeleton? Each of our Formal assessment comes with a scoring guide. And so this scoring guide, remember this activity focused on analyzing and interpreting data. So the scoring guide for that is on your screen, and it comes in our teacher edition packet that was shared with you. So you can see that there's ways to support students in their sense making by saying, instead of like, you're at a level 1, that's terrible. You can say, okay, you're getting started. That's great. Let's move on to the next step here. What could you add? What could you change? By activity 13, the students are getting a lot better at analyzing, interpreting data, so they should be moving up. And then of course, how can this evidence help people understand how they affect and are affecting evolution? So the issue of this unit is how are humans affecting and affected by evolution? So it was really easy for my students to see how we affect evolution with climate and with building houses and with, like the habitat destruction, but it was harder for them to see how evolution affects us. So that's why it was great to step back and look at bacterial resistance and what in the world do we experience where we are affected by that. The driving question board is something that we have for every single unit. This is this entire unit's driving question board. So the issue, how are people affected by and affecting evolution? And then of course, in order to discover and explore that issue, there's some science that we need to know. We need to know that populations evolve, not individuals. We need to know that sometimes those populations change in a long time. Sometimes it's shorter. And then we can cause and be affected by these changes. The guiding question, wrapping it all up, how can embryos provide evidence? At this point, your students should be able to explain, well, it was so hard to tell them apart. They must have a common ancestor. And then of course, it was coming back full circle to your key vocabulary there. Many of our activities have an extension. This extension is just a quick link to a time-lapse video of a chicken embryo developing. One of the things the kids might ask is like, what's middle stage, what's early stage, what's late stage? And we've made it very qualitative because early for the chicken is a lot different than early for the human, because the human early might be the first 2 months. For the chicken, it might be the first 3 days. And so that idea that we qualified those sections of time.
I'm going to quickly give you a 10-minute warning in case you want to start opening up for questions.
Thank you, Mari. So before I go to any more about lab aids and where you can find out more information, does anyone have any embryology questions that they want to, or any like how would we support this remotely? Please feel free to use the chat or unmute. Either way works. All right, so for our curriculum, in addition to our life science units, we have earth sciences.
We have a quick question from Donna. She said, how can this be integrated in a hybrid person in class and virtual?
So if I had to choose which activity I did with my kids in person and virtual, this could definitely be a virtual activity. What you could do is the kids could do the card sort, and the questions at home when they come back to school would be a great opportunity to have that class discussion. What do you guys think? What evidence did you notice to support evolution? The other thing with hybrid is activity 13 could be the asynchronous piece. And then when we come back, we have an activity in our unit where the kids actually get to see fossils. So that I'd want to do in person. So I kind of weigh which activities I'd rather have them touch. These card sorts are great, but I might want to save my touching activity for something that is more lab-based.
Monica said, is there a link with the virtual flashcards open source?
No. So the flashcards that we have are part of our curriculum and on our student portal. So that is part of what we have done for remote learning in our program. If you would like some hard copies of this packet, we do a sampler. And if you go to our virtual booth, I think it's the LabAIDS virtual booth, they'll actually mail you a sampler that comes with the actual cards for you to have a set for your kids.
Donna, going back on the virtual hybrid learning environment, said the virtual takes place at the same time as in person, 5 days a week.
So so do you have some kids at school and some kids at home?
Yes.
Okay, so the kids at school could use the cards. The kids at school could, if you have like a wave to be on the same Jamboard, the kids at home could be working with the kids at school to have this communication and collaboration. The kids at home, the card sort's just super easy online.
Jennifer would like to know if you're going to share the PowerPoint so that they can review the content that you've covered.
You know what? I don't know the answer to that. I know that this is being recorded and that the recording will be made available. So that is, maybe we can check with NSTA because that would be an issue for them, I think.
Jennifer asked you to repeat the comment about the sample, her sound cut out.
Oh, sure. So our sampler packet, if we were in person and we were all together, you would be receiving a free sampler packet. And in that packet, you get the student pages, the teacher pages, and the cards. You also get some colored pencils. So if you would like us to mail that to you, to your home, please visit our booth and they will make sure that can happen.
That is all from the chat so far. I did put the remote learning activity in there for them.
Great, thank you. Oh yeah, the remote packet. So we do have a remote packet that we've designed for this as well. And the remote packet is meant to be something, it's a Word document, but it's easily dragged into Google. And then it becomes a fillable document for students to do on Google Classroom, Schoology, whatever your platform is, so that students can just fill in the pieces of the whole activity. All right, in addition to Earth resources, we've got the life sciences, which this evolution unit was part of. We also have a chemistry and physics unit with lots of hands-on opportunities for students to discover the phenomenon of physical science. The wonderful part is the stuff that you get. And so in this remote world that we're living in, it becomes challenging because most of our kids aren't in person. However, when we do get back to in person, these materials come to you in a kit, all ready to go. You don't have to go to the grocery store every night. You don't have to worry about all those things. Everything's ready and prepared for kids to have hands-on experiences. It's amazing. You get a complete package. So if you order the whole ecology or the evolution unit, you get all the activities and all the supplies to be successful.
I would like to know if we can put up a link for the virtual store. She's having trouble locating it on the NSTA website.
Do you know it, Mari?
I do not.
I don't either. So we'll try to see if we can find, I'll see if I can find that for you. I don't know what the booth, it's like, it would be the booth for the LabAIDS, search LabAIDS is what I'm thinking. We encourage student notebooking, and with digital notebooking, that has become an extra challenge for a lot of teachers because we do want our kids using paper and pen to explore the world. So that is something we support you with. We have tons of literacy strategies that are embedded into each activity. This helps support differentiation for your students. Our scoring guides are based on different science and engineering practices like communicating ideas, analyzing and interpreting data. So that is all in the kit for you. We do have an online portal. Everything is digitized, but we do have paper as well for you to hand out to students, those kind of things. We have a student portal and a teacher portal. Every single unit that we've designed has editable PowerPoints for you to download, drag into Google Slides, figure out what you want to do with that. And they're made exactly following the teacher edition. And then you can decide how you want to keep it exactly the same, modify it, change it, whatever you want to do. We have Spanish editions for our student book and our student activities. all those worksheets. Here is an example of a lab sent. So when kids are absent, this was before we went remote, if we did a lab where students were putting, filtration, how would they make that lab up if they've been absent for a few days and I've already put the stuff away? Well, we have all of the videos for all of the labs all ready for you to go on our portal and post into your student platform. So if you wanted to do this remotely, you could, so with the hybrid situation where if you had kids in person, you could videotape them doing the lab and live stream it to your online kids. Or you could show your online kids the pre-made lab that they would then do in the remote packet. And then in class, the students that are in person could actually do the activity. So there's lots of options here with those videos that are already made for you.
A little 1-minute warning. I'm going to put up the ending poll just to see if it works. If it doesn't work, just put the answers in the chat.
Thank you. We do have remote learning packets. You were just linked one in the chat so that you can go and see those. We have interactive packets as well. So some of our activities, we've done drag and drop type of things instead of students having to draw. And then of course our simulations. Some of our simulations are specifically made for our supplies. So those would be on our portal. And then we now have what's called hands-on at home, where teachers, parents, community groups can buy little kits to go with our units so that at home they could have a few supplies. Thinking about how we're supporting that, some parents are just desperate for like, what can I buy to help my students experience this better? And then of course we offer professional development. And then here is our ending slide. So for more information, labays.com is your place to go with lots and lots of resources. If you can't find the virtual booth for NSTA, you could go to labays.com and do like a contact us and say, I was at NSTA and I couldn't figure out how to get to your booth, but I'd really like a sample of the embryology packet. And I'm sure that would work really well. And that's all. So I will give you a couple of minutes to finish the poll. Please unmute or chat any questions.
I just posted the link for the NSTA lab aids, so you guys can go on there and just click that link.
Thank you so much for doing
Welcome.
that. Awesome.
Are you able to see anyone answer the poll?
I can see the poll. And so I think everybody's voted.
Okay, because I can't see the results. I didn't know if you were able to.
All right, I'll screenshot it. Great. So if you guys have any final questions, let me know. If not, you can click leave and go enjoy your day. Thanks, guys. I'm glad you came.
Thank you.
Thank you.
You're welcome. Thank you.
All right.
That was so weird.
I know.
So it's at one point